All right, let's go ahead and get started here. We're on lesson 4-8, the second to the last lesson of the chapter. Multiplying and dividing monomials. The return of the monomial. Okay, just to make sure we understand monomials real quick, and I'm just going to give you this rundown, and I'll ask some of you probably later on. A monomial is a number, or a variable, or a product of numbers and variables, okay? So it could either just be a number, or just a variable, or just a product of numbers and variables, okay? So that's what we're talking about with monomials. Let's look at our first example. I'm going to go straight to an example, because through the example, hopefully we'll be able to pick up the pattern. Okay, this one is simplify x to the fourth times x to the fifth. Okay, another thing I want to review with you is what is on the board right now. So you don't have to write these in unless you already know, but please look up on the board because I'm going to point out some things that hopefully make things clearer for you as we work this out. Okay, this is an expression right here. This expression is called a power. This is also a power. What's happening with those two powers? What operation is going on between the two powers? Marissa? They're being multiplied. Do you guys agree? This power is being multiplied by that power. You guys agree with that? Okay. Looking at just the first power, this number is called the, does anyone remember?
Base.
The base. In the second power, what's the base? 8, right? It's 8. It's that big number. And I heard you guys talking about coefficients, right, and subscripts. So it's not necessarily that, but when I say big number, I just mean this base and the base. Do you notice that the bases are the same in both powers? Okay. And then what's this number up here called? Exponent. And what's the exponent of x to the fifth? What's the exponent of x to the fifth? 5. Good. So we just identify parts. Okay. Powers are being multiplied. They have the same base, and they have different exponents. Okay. I'm going to do this a long way, and I want you to do it this long way real quick. We're not going to do this every time because this long way is long. I want to make this simpler. Does anyone know what 8 to the fourth means with multiplication? I don't want to know what 8 to the fourth is. That's a big number. I just want to know what it is with multiplication. Callie? Yep, 8 times 8 times 8 times 8. Would you guys agree with that? That's 8 to the fourth is right there. What's 8 to the fifth mean? Yes, ma'am? 1, 2, 3, 4, 5. Okay, is that 8 to the fifth? These are all being multiplied. These are all being multiplied. And what's going on between this and that? Multiplication. Oh my. Okay, get your finger. Yeah, you could put them. And we're not going to, because we're not going to do this forever. But you could. Yes, you can, and then you can drop them off. Okay, get your fingers out because we're going to start multiplying here. Okay, 8 times 8.
64.
Times 8.
64 times 8.
Oh, wait. No. This is not the point of this lesson. I want to make it simpler, not by finding it, because this is a huge number, by the way, guys. Huge number. I can look it up later. I don't know what it is off the top of my head. There's no way I'm going to figure it out in my head. But we can make it simpler. How many 8s are being multiplied altogether? Altogether. How many 8s are being multiplied? Max? 9 of them. So can I write this in exponential notation using a base 8 and a certain exponent? There's a specific exponent that will describe what's going on right here. Yes, ma'am, Elizabeth? I don't want to say 8 to the 9th power. That's the simplified form. Right? Does anyone see the pattern? Does anyone see how I didn't have to write 8? Okay, I think I lost count. Wait, it's 8. So how can you do it a lot simpler than just writing all of them and counting them all out? There's got to be an easier way. Jack? Okay, boom. Here's our property. It's here. It's called the product of powers. This is what I need you to get. Product of powers. Some of you are thinking, Mr. A, I don't know why you said boom, because I don't know what's the boom all about. Okay, here it is. It's the product of powers. This is one of the properties that we're going to use with powers. Okay, here it is, and I'm going to put it in algebraic terms. So it won't be in 8s, but it will be, we'll see how it applies, all right? A to the m power. Okay, it's some base to some exponent. Times a to the n power, or to the nth, we would say. I know it's strange to say nth. Nth. And that would be a to the mth. Nice ways to say it. Is equal to a to the m plus n.
So would it equal mn?
No, m plus n. And that is not mn, but that's a good way to think of it. Let's see if this actually applied to our problem here. Ready? All right, so I'm going to keep that up there. Oops. Smartboard's been giving me a hard time this morning. All right, here's our product of powers, and this is super important. So I need to know this because it applies to half my problems. Okay, the problem we had initially was 8 to the 4th times 8 to the 5th, and we said that equals 8 to the 9th. Okay, ready? You must go through this process before you figure out the final simplification. Ready? Okay, are we multiplying powers? Right here, are we multiplying powers?
Yes.
Yeah, what's this called? What's that called? What's going on between them? So we're multiplying powers. Do they have the same base?
Yes.
If you're multiplying 2 or more powers with the same exact base, what do you do with those exponents? Add them. So we get 8, the same base as the other two, with the exponent of 9. That's the product of powers property right there. Boom, right there. That's the answer. Okay? Let's see if we can apply it to some other problems. Look on page 207, number 5. 207, number 5. This is 10 to the 4th times 10 to the 3rd equals, and we're trying to figure out what that equals. Now, you could write 10 times 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 10. How many 10s altogether are being multiplied? And how in the world did you get it, Tristan?
7.
So what would be my final answer?
10 to the 7th power.
10 to the 7th power. Okay, that is correct. And the reason is this. Are we multiplying 2 powers? Yes, right? You're like, Mr. What are you talking? Is this a power? Is that a power?
Yes.
Do they have the same base?
Yes.
Yeah, they both have 10 as a base. So what do you do with those exponents? Add them. And what's 4 plus 3? 7. 10 to the 7th. Yes, ma'am?
So since it's like 10 times 10, like, so when you say it's like 100 to the 7th, it's like...
I say you're saying, like, shouldn't you multiply these two together, get 100, and then 4 plus 3 is 7, 100 to the 7th? Well, let's do this. Because we kind of understood this one because I showed you all those 8s being multiplied, but I'm looking at this one right here specifically. Does anyone know what 10 to the 4th is? I think you guys could figure this one out quicker than 8 to the 4th, because I don't know 8 to the 4th.
10,000.
Okay, it'd be a 1 with 4 zeros. You guys agree with that? 10,000, very good, Max. What would 10 to the 3rd be worth? What's 10 to the 3rd, Braden?
1,000.
1,000. Okay, so would you all agree that 10 to the 4th times 10 to the 3rd is 10,000 times 1,000?
Yes.
Okay, so now what I need you to do is tell me what's 10,000 times 1,000? I was like, So I need someone to give it to me exactly.
1 and 0. Oh, yeah.
It is 1 and 0. John?
10 million?
Okay, he says 10 million. Here's what I'm going to do. I already know it's going to have a 1, and it's going to have 1, 2, 3, 4, 5, 6, 7 zeros. So, John, you are correct. It's 10 million. And you're like, no, that can't be 10 million. So here's what I'm going to do for those who are maybe skeptical, which is okay. Do you guys ever multiply like that? Does anyone let those zeros hang out?
No.
Okay, that's one way. When I multiply by a number that has zeros at the end, Watch what I'm going to do. I'm just going to multiply by 1. What's 1 times 0? 1 times 0? 1 times 0? This is fun. 1 times 0? 1 times 1? 1. And then you're like, but that can't be the answer. And then you just bring down these zeros, and that's your answer. 10 million. So you didn't have to multiply by 0, because what is 0 times anything?
0.
So you just kind of let those hang out. And they come out at the end, but you don't have to actually work them out. But do you guys see how I can work them out? And either way I get that. Is 10 to the 7th 10 million?
Yes.
So you can either go this route and work it out and then convert it back to a power, very nice, a power. Or you could just keep the same base, and then add those exponents. So does that make sense, Sydney? Keep the same base and then add those exponents, which is really nice for actual like math work. Okay, let's look at another one and see if we're really getting this. Oh my, number 7. 3 to the 6th times 3 to the 4th. I want us to simplify that. I don't want to know what the final value of that is, but I do want a simplified exponential form. So I'm going to ask the whole class a couple questions, then specific people some questions. All right. Are we multiplying powers?
Yes.
Yes. Power, multiplied. You guys okay with that? Do they have, everyone, the same base? Yep, they both have a 3 as a base. What do I do with those exponents? Josie? Add them. And now I need an individual to tell me what do I get, because that's the whole point. Caroline? 3 to the... That's it. Yep, because 6 plus 4 is 10. 3 to the 10th. You guys get that? That's if you're multiplying powers. Do you guys understand that? I keep saying multiplying. Powers. Same base. Add the exponents. That's a process, and we go through that. This is Algebra 2 stuff right here, guys. It's Algebra 2 stuff. And you're like, whoa, that's easy. Yeah, because it gets tougher. Because remember what I told you about exponents? Are exponents only whole numbers? They become fractions later on. And they can actually, exponents can have their own exponents, which is really cool. It's like, yeah, it gets complicated, but you'll be ready if you get this. Callie.
So if you, are number 8.
Okay, number 8.
If you're adding and you multiply, you subtract.
Sorry. He took my thunder. Okay, we'll talk about that next in just a moment, but I'm going to give you the toughest problem I can for this first part. Go ahead, question. Go ahead and do 9 if you're okay. Yes, sir, Brady?
What if so let's say on the thing, on number 7 we just did, what if it was 4, 6 times 3, 4?
So you said 4 to the 6th times 3 to the 4th, so this was a 4.
Yeah, 4 to 6 times 3.
So do they have the same base anymore? So you cannot combine them like we did there. They have to have the same base. Good question.
What would you do if they don't have?
The only way to simplify it was to leave it 4 to the 6th times 3 to 4. That's it. That's all you can do to make it simpler. Okay. Sorry, this is 8 to the 2nd times 8 to the 3rd. Times 8. 3 numbers. Okay. Are we multiplying powers?
No.
Yeah, okay, I get this. That's a power. And that's not a... Remember, 8 to the 1st is equal to 8? So that... Okay, hold on. Let's see if we can work through this. Do you have a question or an answer? Okay, I'll ask the answer from Tristan in just a bit. Are we multiplying powers? You guys agree we're multiplying powers? Power. Multiplied. Do they have the same base?
Yes.
So what do we do with those exponents? So what do you get, Tristan? 8 to the 6 is your final answer.
24 to the 5th.
No, because 24 to the 5th would be 24 times 24 times 24 times 24 times 24. And 8 to the 6 would be only 6 factors of 8. And that's going to be a significantly lower number. Yes?
So 8, even though it doesn't have an exponent, it's just automatically 1.
Yeah, Because it doesn't have it written there, it still does have it there. We don't have to write the 1, but for us to understand, especially in this problem, yeah, it's there. Say that again? Yeah, remember, what does any number to the 0 power equal? 1. And there is a reason behind that. I will show you that tomorrow. We will go over why. Okay, I kind of get 8 to the first means 8, but why can't 8 to the 0 be 8? Or 0, or equal to 0. It's not, and I'll show you, but that's tomorrow. All right, let's look at 2a. Example 2a, so I think that's page 206. Variables. N to the second times n to the fourth equals, I don't know, this is variable territory. This is not numbers.
I know.
Jack?
It's n to the 6.
Oh, okay. Yeah, because n stands for a number. Are we multiplying powers? Multiplying powers.
Yes.
Do they have the same base?
Yes.
Add the exponents, and you're done. Keep the same base, add the exponents. You're done. You guys get this?
Yes.
Done, done, done. The hardest problem in your homework is going to be related to B. This one's tougher because there's a lot going on. Negative 6x squared times 5x cubed. Okay, I need you to pay attention, please, because I want to help you out. So please look up here. Write this down and start looking up here, and I'll point some things out for you. Okay, I'm going to take this little bit at a time, little pieces at a time. What's going on between negative 6 and x squared? What operation? Marissa? Multiplication, right? These are being multiplied. What's going on between 5 and x cubed? Emma Grace? They're being multiplied. You guys agree that these two are being multiplied and those two are being multiplied? What's going on between negative 6x squared and 5x cubed? They're being multiplied. You know what's going on here? It's a giant multiplication problem. And you should remember, there are two properties of multiplication that help me to do it in any order I want. Okay, ready, guys? So I'm going to erase these lines so it doesn't get too tricky. Okay, are these all being multiplied together? Does the order of the multiplication matter? No. So watch what I'm going to do here. I want to multiply negative 6 by 5 first. And then I want to multiply x squared and x cubed. Is that allowed?
Yes.
Because if they're all being multiplied, I can do it in any order. And in fact, I'm going to use which property when I do that? Commutative property. When I rearrange, I use a commutative property. Now I'm going to use another property. Ready? Hold on. Ready for this? Hold on. I want to group these two together. I'm using the associative property. Yes, you are. You got it. Associative. So what's negative 6 times 5? And what's x squared times x cubed? That's my final answer.
Wait, so why on the other ones did we not multiply them? Like, then it would be, wouldn't it be?
So, like, are you thinking A?
So, no, on the 8 to the second, A to the third, we multiplied the base on this one, but we didn't multiply the base on that one.
Gotcha. So, we're using, these are powers, aren't they?
Yes.
Are these powers?
No.
So we treat them just like we would numbers. We're treating these with the new rule that we just learned.
Okay.
Good question. And yes, technically you can even say they are, because they both have 1, but they're not the same power. And anyway, we deal with them like numbers, like negative 6 times 5. Just like normal. Okay. I think you guys are doing well. Let's do the last set here, example number 3. And this one's different. Callie, you actually alluded to it already. 3a. I'm confused about this one. 9 to the 7th divided by 9 to the 5th. Hold on. Mr. A, you just said divided by, and I see a fraction. It's the same thing. You should be able to go back and forth, back and forth. You got to go back and forth. Okay, but anyway. Here's the long way of doing it. Can I do the long way? And then you show me the short way. Ready? So do you guys remember this? 9 to the 7th, how would I write that with multiplication?
9 times.
Okay, ready? 1, 2, 3, 4, 5, 6, 7. All right. And how do I write 9 to the 5th? You know what? This next property, you've already done it. You've already done it. But I'm going to show you a couple different ways to see, well, wait, what are we talking about? Do you guys remember when you have a fraction like this and you have common factors, can't you just cancel them out? How many of these can I cancel out? How many of these can I cancel out?
5.
5 of them here, that's a big fat 1. And 5 of them here, that's also a 1. So I'll erase this one so it's not confusing. So what am I left with? Well, what's 1 times 9 times 9? 9 to the... And what's on the bottom? Over 1, which can be taken away. So what's my answer? Yeah, it'd be 81, but we're just going to write it 9 a second.
You're just subtracting out. So if it was the other way, wouldn't it be negative 2?
Yeah, and we're not doing negatives today. We're doing that tomorrow. We'll get to negatives. Oh my, negatives. Okay, here is the quotient. This is the second property, the quotient of powers. The quotient of powers. And you're like, what quotient? What does quotient refer to?
The answer to a division.
Division. What does product, the last one, refer to? So we're talking about multiplication division, weren't we? Quotient and power. Or sorry, product. All right, here it is. A to the m power divided by or over a to the n power is equal to a to the m minus n. And you're like, wait, what? So I'm going to tie it back to the last example to make sure you guys understand. So stay with me, guys. Stay with me. We're almost there. Okay, so here's my quotient of powers. And you're like, what does that mean? Let's look at the last problem we just did. 9 to the 7th over 9 to the 5th. Okay, please pay attention. Are we dividing powers? Are we dividing powers?
Yes.
This is a power, and that's a power, and that's division. Do they have the same base?
Yes.
What can we do with the exponents? So we keep the same base, and what's 7 minus 5?
What?
7 minus 5 is 2. That's okay. Maybe he's thinking something else. You guys see that? Let's do a couple more and see if you guys really get this. Number 6 across the page. So number 6, 2 to the 5th over 2 to the 2nd. So number 6, 2 to the 5th divided by 2 to the 2nd. Or you could say 2 to the 5th over 2 to the 2nd. All right, ready? Are we dividing powers?
Yes.
Do they have the same base?
Yes.
Yes. What can you do with their exponents? Subtract. So you get 2, 5 minus 2, 3. 2 to the 3rd power. That's what you're doing here. I'll give you 2 more here, and I'll let you go. Yes, sir. Number 8. Do it if you can.
So couldn't you just pretty much subtract?
Yes, but the thing I'm trying to get is because one of the common errors, Braden, is people are like, oh yeah, you're going to subtract. So you actually subtract 8 minus 8, and you get your 0 to the first. That's not correct. And that's not very common with numbers. It's with the variables that people start tripping up on this. Okay, ready? Do we have powers being divided? Yes. Go ahead.
What about if it was 8 to the 3rd power over 8 to the 4th power? Would it be negative?
It would be negative,
I already said that.
which we'll talk about tomorrow. So don't worry about your homework today. It won't do that. But that's correct. Okay. What do I get here? 8 to the...
First or just 8?
Yeah, you can say 8 to the 1st power, or you could just say 8. Aren't they both the same thing? Okay. Last problem. This is the toughest one. Yes, ma'am. Marissa. Yeah.
So say for the number 8, say if you had 8 to the 3rd on the top and 8 to the 4th on the bottom, wouldn't it be like a negative number?
Now, today, don't worry about that on your homework, but tomorrow we will get to that. So we're going to get, tomorrow's lesson is negative exponents. What do we do with those? All right, this one's 12. AB to the fourth over B to the second. This one's tricky because it is not as clear as the other problems. But let me ask you this. Can we combine A and B to the fourth together? Well, that's a power, isn't it? And so is that. And I thought we just learned about product of powers you can multiply if they have the same
Base.
Do these have the same base?
No.
You can't do what we just did on the other problems. But does anyone look at these two right here?
Yeah.
Can you do something with those two?
Yes, you can make it B to the second.
Okay, so what would my final answer be?
A, B to the second.
A, B to the second. You're just dealing with this part.
What if you put A times?
Don't mess with A. Sorry?
What if you put A times like A dot?
Same thing.
Then just see, but erase it now because we're going to see it like that. So yes, they are being multiplied, but take away that dot because that makes it simple.
This homework has to be easy.
I hope.
No,
Okay.
look on page.
We are done with that lesson, and please listen up, guys. Again, I'm trying to help you out here.
We're done?
Look at your examples to make sure you remember how to do these things, because if you're not sure,
Hey, I don't have my book, so.
all right, your homework tonight is, today is Tuesday, correct? 15 to 37 odd.
Yeah, today's Wednesday.
15, oh, you want more problems? 15 to 37 odd, and then 51 to 53. And that's going to be pages 208. Oh, I put the wrong number there. 208 to 209. And that's due tomorrow. Go ahead and get working. You have about 10 minutes, so you have some time.